Hello, everyone, and welcome to the broadcast. I try to get started right around 4. I have to deal with advertising over on the Twitch side, so it can be a bit of a wind up when it comes to the stream. So I keep that starting soon going. But in any event, welcome. Let's see. We were already joined by Manuel over on the short form stream. If you see or if you hear me talking to someone that you can't see in chat, they are probably in one of the other 2 streams. But we're going to be coding our game some more. We ran into a performance hitch at the end of the last stream, and I've identified the problem area. Fine-tuning that and solving that is going to be first priority for the stream. We need to get back up there to being able to summon thousands of bullets at once. Let's check in with the kitties first. We do have Ember across from the keyboard. We have Sky up in the cat tree. And we have Mason and Sammy over on the bed. Sherbet is MIA, but he is kind of elusive. We'll see if he shows himself. But let's switch on over. Classically, let's keep the camera on the bed. We tend to get a lot of kitties there. All right, but this is our problem zone. This is when we spawn a new thing and we rig up the collision for it. So we're just not going to rig up the collision. Come on, camera. You can do it. Now let's switch it and force it here. Sometimes the camera switch misbehaves. Okay, so this is without the collision. We're spawning, this is about once or twice a second here, with 2 of them spawning. So we're going to make this one spawn, let's see, 3 to the 5th at once. And I think they go away after like 3 seconds right now. And then 3 to the 6th. 7th. We're right about at our limit of 8,000. But you see, no performance issue. Now, we're going to put collision handling back in. Testing here. Yeah, okay. Fourth and 5th. Holding pretty well. Okay, what's going on? There we go. So at about 3 to the 6th, we're definitely having the issue. This is not necessarily a real use case, but we want to be able to have ridiculous stuff in the game. And spiral them. So it costs us even more frames when we're moving them. Drop it back down. We can get back to 60 frames a second. So we want this level of smoothness all the time. So our first experiment is going to be, how can we make it so that the shape handling is super smooth? Eventually, it shouldn't be that the shapes are terribly expensive. There's a shape attached to each yarn ball, and it's moving around like crazy. Welcome back, Todd. Welcome back. Okay. So what can we do here? So again, our problem is, once we are creating enough entities, we start to have a big burden on the system here. Where we've dropped well below 30 frames a second, which is already unacceptable for us. We can handle 3 to the 5th moving projectiles. Here's with 3 to the 5th with 2 movement patterns going at once. So normally this should be okay, but again, 3 to the 6th spawning at once gets us problems. But we shouldn't be having problems with the physics server right away. So one of the things I'm going to try is generating enough, like all of the shapes up front. Does that make a difference? So we add a collision area. We create a range, a possible range of shapes equal to twice the entity manager's max entities. We set up the collision area. Get the collision area here. Area RID. Okay. So we're going to do this part here. Like that. And then we'll do this part. Okay. So we're going to get the resource identifier for the area. As a reminder to those that aren't used to the stream, or as a notice for those that aren't used to the stream, we are coding a game. And that means there's going to be a lot of code on screen. If you're in the tall form, it's code. So there might be elements that aren't terribly visible to you. I do get locked in a bit once I'm concentrating, but do not feel that means I can't chat. I can always stop and chat. It's equal to 0 I is less than Wait a minute. Okay, no, that's a stack value, so that's okay. I plus plus. I. Okay. for each area, we are going to generate all of the shapes up front. And we're going to see if that makes a difference. Which means there will probably be a hitch immediately. That's not good. Okay, well, it's not breaking here. I think we may be encountering our problem already. Hope it's not raw number of shapes. Run it through Godot and see if we get a different result. Yeah. Okay. It's pure number of shapes. Pure number of shapes. Maybe we're just getting an error case here. Let's not jump the gun. First, let's move all of this up above turning it on. So this is before we're having any of the collision events happening. Still getting an issue. Let's look up our entity shape logic here. So we are going to it's a bit hacky here. It's an RID, shape, and radius. What doesn't it like? Ah, okay. And where are we enabling it? Okay, that should be in our collision manager. Our Okay, we are disabling them all up front. And we're not monitoring or being monitored until this moment. So there we go. Okay. 1, 2, 3, 4, 5, and 6. It's slower. Slower. How can we mitigate this problem? Got to be a cleaner way to handle our collisions. I mean, to be fair, let's see. 1, 243, 729. Technically like 2,000 some objects here. So, I mean, this should be too many, but based on the way that I'm setting up the system, it is technically possible to have this. Where every time we do this, we are attempting to create 3 to the 10th, which is... um, 59,000 things. We can't create that many at once. We can't create that many at once, but it is having problems. Okay, so what can we do? It is not the fact that the shapes have to be fully created each time. So that's not really our problem. That's not really our problem. It is interacting with them each time. What if... Okay, we are never enabling the shapes. We're still going to move them around. Okay. We hold about in the same area if we never enable them. So it's not just the collision checking. This is never moving the shape. We never move the shapes. Five and 6. Okay. Just the shapes existing. Huh. Else. Right. Let's try some other variables here. One of the things we added last time was standard catalog. Something quick. Why is this under a different heading? These are all in different folders too. Anyway. Okay, we go into here. We're looking for our load entities. Scroll down to find our yarn ball. This is where we're adding the death timer, which will remove entities. That did not ultimately matter. There was still a hitch when we created that many. Okay? Number of shapes in the collision area seems to be our problem surface. What if we do two different collision surfaces? They can collide with each other, so there's an extra variable here up front. But let's try it anyway. We are going to pull this down. They're going to spiral out, and we're going to add a timer lifespan on them too. And then we go into our inventory, I believe, and we're going to add that. First we go over there, we find our spot. That. We're going to add the blob, which isn't actually a weapon, but it spawns the same way. It's supposed to spawn the same way. So we have a problem. It's not an item. It's not an item. Has to be an item. Okay, I don't have an icon created for the blob, but it's item nanoblob. Okay. It will just have a circle icon. Like that. They're immediately colliding. That's not... We should be able to solve that, though. Okay. Okay, we should be able to solve for this. See how there's 2 being created each time. Okay, we are creating how many items right now? Creates a much more erratic pattern doing it this way. 243. We're creating 486 at a time. The failure case was more than this. But I don't want to put a 6th multiplier here. What I'm thinking with this is that we might have to have a numeric limit to the number of shapes that can be in any collision zone. That is, okay. That is, we can't have too many of the shape objects stacking up. So the bullet zone currently has a limited number in it, and that's okay. But as soon as we do this, I think we're going to run into the issue. Yep. So this is not a one-to-one. We can still solve for this. We're going to remove these spiral outs. We're going to go into standard inventory still to have 3 rows. We need to have 3 rows for weapons, I should say. And then in the standard inventory, when we load up, in our ready, we are going to add we need we're gonna test for this further. We're gonna be creating a similar number of things in each group. No. Okay. So to really bear this experiment to its fullest, what we would need to do is have several sets of collision layers in order to handle the number of them. That is, instead of having like one collision layer for each type other than the player will never need multiple collision layers. So we could have special handling for that. But bullets and enemies technically can have more. And it makes sense for them to have more. So what I could do is that each area could have a limited number of shapes, and we could cull it down accordingly. But how do we do that? We could have the shape IDs subdivided. Down to a limited number of shape IDs per pool. And if the shape ID is greater than a particular threshold, we reduce it by that threshold as many times as necessary and determine the number of iterations that took in order to determine which pool it goes into. So this is an integer division followed by a modulo kind of thing. So let's say we allow 1,000 things. It's more than that, actually. Let's cull this down. Right now, we're fine with about 3,000 things in the same bullet group. But as soon as we get this far with collisions, as soon as we get that far adding them, we start to run into issues. Now, it's possible that the hitch that happens by doing this is because of the number of collisions we're creating. Because the things we're adding collide with the bullets. Okay, actually, this case that we have right here is actually the problem case. We are creating 3 to the 6th things because we have 3 to the 5th things. But if we look, 3 to the 2nd plus, 3 to the 5th times 2 plus 3 to the 5th, 3 to the 4th is not too much. As far as creating things. Now, we could be getting a variable here. So let's change the blob to a yarn ball. Just so. Fifth. The 4th. This is fine. Let me do some quick math here. Okay, this is still, if we look here, we are getting some degradation. We're going to crop it down 3 to the 3rd, 2nd. If we say 500 objects per layer, That's about right. Because this is 486 things being created at once. And we're fine. Number in existence doesn't seem to matter so much. But it's when we're enabling and disabling shapes with it, I think. Because every one of these is actively moving a shape. Is it just the raw number of them that are coming into existence? So here's about 3,000. We're still okay with this amount, but we're getting a fluctuation. $397 is the... Okay, so here's over 3,000 objects in the same layer. Now we're consistently over 3,000. We've hit 4. There are no collisions happening here. There is actually nothing that can collide with them right now. The player exists, but the player layer does not collide with the bullet layer at all. Okay, we're going to drop this back down. So we're back down at about 3,000. Okay, and let's drop under 3,000 here. Consistently under 3,000. We do get a little twitch over 3,000. If we drop down further, now we're well below 3,000. This may be our actual problem. Is number of things in any given collision layer. There's a lot of extra math that we're going to be doing going down this road. But if we have a number of shapes maximum, and each collision layer is handled accordingly. So let's say 2,000 per layer. And we're going to limit ourselves to 10,000 objects. We will create that many layers. We could also create the shapes up front, but we don't need to, I think. Ultimately, the problem surface doesn't seem to be in the creation of shapes. It is in the number per layer. So how do we want to do this? Everybody following what we're getting at here? Oh, dear, dear, dear. Okay, so recapping. It looks like... So, recapping further, or at least explaining further. Every one of the things that you see, the moving yarn balls, the player, when we had the blobs in here, the blobs, each of them goes on a particular collision checker. The player is on one, the yarn balls are all on another, and then the blobs were on a third. The player, blobs can collide with the player. Bullets can collide with blobs. If that pairing is not present, then the collisions can't happen. As far as the yarn balls and the player are concerned, they're invisible to each other. They don't exist to each other. The blobs check on the player. The player is in a layer all by itself. So ideally, we'll only ever need one enemy layer. It's the bullet layer that is special. I don't like having to treat them special, but we might need to. Or it might be reasonable to. Okay. So let's look at our collision manager here. So this is when we add it, and we're getting our collision area from a flat area based on the category. We could replace this with a function, get collision area with a type in it. And then we could break that down further. So we'll call it protected. Why not? Public collision area. Get collision area. It will always return one. We would also need to know the index to use. This is whenever an entity is added. So we know which one to use as soon as we've got an index. We'd have to do this first. Otherwise, when we get a collision or a shape removed, we still have to get the index first. So we need an index to deal with, and we need a type. Don't actually need this int indicator here. Entity category used to be an enumerated type, which we would have to return. So we need a int entity category and an int shape index. So we could just do this like that. And then we can replace it with a call this for now. We should get the same results. Okay, same results currently. This is fine. Want to add the blob back. We're getting some collision added in here, so there's some extra work that's happening because this layer, the bullet layer, has something to collide with. But the collisions are still way cheaper than entities in existence. Because if this were bullets, we would be decaying down, but because the collisions are happening, we're reducing the number of bullets that are out there. So despite having, every time we propagate this, there are, like right now we've got 27, 81. Okay, so this happening is enough to cause too much logic to happen. We're going to need to visit this again as well. But again, this is, we are having 81 collisions at a time, every time. And that's keeping the number. We're going to have it where collisions can be eaten. We currently don't have that logic, so we're having multi-collisions. But this is 81 collisions every time this happens, and we can hold pretty steady. This is way more than 81 collisions. We can actually determine how many we're getting at any one time. If we do this, five, 2, 3, and 4. Running through Godot can make it faster sometimes than running through C#. It removes one of the layers of dealing with it. We're going to go to monitors, and we're going to add objects, physics, collision pairs. Okay. Sadly, we can't. Realizing again, we're not using Godot's visual physics logic. Even though there's big collision bodies with lots of shapes, Godot can't actually draw them. So if we look, here's primitives drawn. We're sitting at all times under 13,000. Let's let the number run up here. And it's spiking up substantially. Because we have a lot of things at any given moment being drawn before they're removed from existence. We have one orphan node. I don't know where it lives, but yeah, we'll find it. We're tabbed away looking at the monitors. It's more expensive for it would seem. So yeah, I think it's existing at right about the 3,000 mark. If we limit it to about 2,500 per layer, I think we're pretty good. We could say 2,000 to be safe. It's a nice round number to do math with. And anything, so instead of there just being one bullet layer in this case, there would be X. And that X would be rounded up the max per layer, the maximum entities divided by the max layer. So we'd have to do some floating point round up here. So we determine the max number of layers from that, and then we calculate the layer by doing integer division of the index that we get. So as far as shape indices, we still have the same maximum. We'll still iterate it way out, but we would determine which ones to use differently there. We are going to be heading into an ad break shortly, so in about 5 minutes we'll pause for a quick break. But let's see here. How are we going to do this? It all comes down to the way we handle this get collision layer. So we have a category and an index. Let's assume 2000 for now. So when we initialize here, add collision area. We're going to do this each time we'll connect it. Oof. This is tricky. So when we get a collision, though, we just have the two areas in the shape index in them. But that means we aren't going to have updated collision area collided. We get a minute. Collision area collided. Okay. That's because the collision area knows which category to deal with. Okay, we're looking at a non-trivial, but I think attainable refactor that we're going to be dealing with here. We need to change the collision areas to have knowledge of which index they're actually going to be dealing with, because they're going to report different things. So here, when we invoke it, we're saying what our category is, and we're getting that stuff back. But we could report things differently here. So collision area collided. Whoops. on collision area collider. So we get the category that we're going to use. We're getting the category, and we're getting the shape index within that category, which gives us the shapes. We could still have that. We're storing the shapes purely by shape index and category. Okay, so I think we should be starting an ad break over on Twitch. Let me... Yeah, there we go. Okay, it's break time. I will be right back, folks. Okay, I'm back. Still got, 40 seconds or so on our ad break. But for those that don't have the ad breaks, chat a little bit. I think we found our issue. We have not yet made any code commits. So the goal here is to either get this working or be able to back down and revert back to where we were when we started today. So get the entity category. If the thing knows its shape index adjustment, that is, so say 2000 is our limit. I'm sorry, our adjustment. So the first 2000, 0 through 1999 as far as indices. The offset will be 0. if the shape index that comes out of the collision is 0 and it is group 2, then its offset is 2000. We add 2000, and on and on and on. That will mean that as far as the category and the shape tracking is concerned, we have the same list where, so collision area entity shapes. Yeah. So we've got dictionaries of a index, and this index is tracked across all of the collision areas total, or for an entity category total, we have an entity shape, and that shape doesn't care which area it's in. Each collision area has an entity shape in this scenario. All right, how do we want to do this? On entity added. Let's look through here. We get our area. We grab something from the shape index for that area. Is this really going to be a problem? Do I really need to have something more extensive here? Yes. We need the global index across the whole category. It can't be just for an individual collision area that we have that. I see you've moved, Ember. I think briefly Sherbet took her spot because she's got that angry loaf going on. Yeah, let me show you. So you can see Ember, she's the one with the orange splotch over her right ear. That is her displeased loaf. See, her ears are a little bit back. And she's sitting in loaf position. She normally likes to relax kind of on her side. Or if she's going to be loafed, she'll be loafed on the blanket, the comforter that Mason is on the bed, the upper right gray one. But that's for, like, sleeping through the night. So slightly different posture there. She generally only loafs like that when somebody else has taken her spot. And her spot is top center for wide view or upper left for tall view. Sherbet's passing through the play area. Bit of a big stretch. But anyway, so we need the global index to know which collision area needs to contain that entity. But the collision area itself will be able to tell us which shape ultimately gets the collision. And when we remove an entity, we need that that shape has a global index and a category as well. So those are the two things that we need to deal with here. Well, no. The global index is the thing we need to deal with, which means the add collision area logic can't be the part this part can't create the shape indices. That will happen outside of it. So it should have its own entity shape collection. That's fine. Because that's what we need for collisions. That's fine. But this is the part that would need to change. Because we're doing this for each area that we're creating. And this range that we're creating is going to be whatever our max entities per layer is. So we need to move this up into our ready function. Okay, so for each one of these, we need to set up this indices is equal to this. That for a moment. There. Indexes is equal to. So then for each one of these, that we create a new listing here. We're going to have a special case handler here. But that should be fine. This should be fine. Static int. Thousand. Collision areas have a max shapes, we're going to say. Get rid of this. Need to do this for each one. with some variability down here. This is part that will vary. We're going to create multiple collision areas, but we're going to keep the shape indices the same. So we might be able to get more entities in the world if we do it this way. Player will have the same number. Bullets will have the same number. Okay. I is equal to 0. Hey, vampire. Welcome. We are trying to fix our collision area generation because what we've discovered so far is that there is a practical limit to the number of shapes we can have in a collision layer, at least a Godot standard collision area. Could we potentially create a custom collision area? Yes. But we've tried that and it's kind of fiddly. So for the time being, we're going to keep it the way we have been, but we're going to limit the number of shapes that goes into any given one and try to handle it that way. If that doesn't work, we can do more drastic things. And Vampire, we're doing well. We're doing well. We determined just before stream what our problem area was, and we're moving in to try to solve it. Okay. We should be able to determine the number of areas at maximum up front. This is as a float. Oh no. Yeah, as a float. This. Divided by as a float vision area dot shapes. Then we are going to is there an alternate round we can use? ceiling. Okay, yeah. Ceiling of this. Oh. Double. Then as an int. Okay. So we have determined that there will never be, ideally, without airing out, there will never be more than twice the max number of entities. So we have way more room than we should need. This is excess, but one of the things we want to... This shouldn't be a problem. We should need to do this. Even if we hit max entities and we have to fiddle with the shapes, it's all happening sequentially. The physics layer is handled in its own world. That should be okay. Okay, so we're determining how many areas per type we should have. The player one is going to ignore that. The player one, if we were to have more than 2,000... I'm sorry, if we were to have, more than 2,000 player objects, we have a problem. There should only ever be one, so... I is less than areas per type. It's plus. So we add a new collision area for each one. We are going to need to add collision area its offset. But first, let's get this in place. We're going to move that logic up there. I don't know what it is, but recently YouTube chat, at least for me, has been disconnecting and reconnecting kind of regularly. Hopefully you folks aren't seeing that or encountering problems with it. We'll see how that go. Clicking some things. Create the indices, and then we add them. And then we add the collision area. I could create the indices all at once, but we're going to keep it all together here. You. In some curly braces. So then when we call add collision layer or area, go to which type it is considered, which type it collides with, and we are going to have int offset index offset. Index offset. Area dot max shapes times I. Okay, what should this do? So what game am I building? I am making a Vampire Survivors style game with a, ideally, Noida style weapon builder. So not ready to mess with just now. We're making a bunch of changes, but the idea is, instead of like, you got Boomerang, and Boomerang moves exactly like this all the time, and as it's upgraded in a linear path, it gets slight changes to behavior. It would be things like, you got Boomerang, but you put this modifier on it, and now instead of moving out and back in, it moves out in a spiral and then tries to move back in, influenced by that spiral. So the roguelike aspect of it is going to be dialed up tangibly. But right now we're working on a performance issue. Hopefully I'll be able to show folks something visual shortly. But what I'm doing right now super breaks it. Okay. By doing this, we should no longer care adding collision areas. So when we add it, we need a new marker, because collision areas, where else are we using you? Get them. We get their index. Anytime we need to get a collision area is when we're using that category. So collision areas needs to be two-dimensional. I am going to be talking about the code a lot. I am going to get focused in on the code, but do not worry about that. Ask any questions. Just chat if you like. and I can make time to answer, to talk with folks, whatever. Let's look at what collision areas is. It is currently a dictionary of integers of collision areas. And instead, it could be a dictionary of dictionaries. That is, each collision area is going to be added linearly. That is, whenever we call add based on which category it's in, it's going to add it to that list so that we still have a proper collection of them. Okay, so it's read-only. We should still be able to interact with it and add stuff to it later properly. Yep. We're going to leave that named as it is. We might shift that identifier over to something else because it's technically not accurate anymore. So what it'll be is based on which category we will have a we will be able to get an entity shape based on the identifier, essentially the index of it. And that index will be provided by the collision area subsequently, or we'll be able to extract that. It's a cycling list of them. Gonna have to take another break real quick. Sorry to do it shorter than normal, but I will be right back. Sorry about that. We're back. Okay, by doing this, the collision area index will be a little off. List of collision areas in use. Behave. Normally, you try to be so helpful. Okay, for each in areas, Okay, and this is the cleanup. This should still work. During the cleanup, we go through a physics area and we go backwards through the shapes because every time, in theory, we could remove shape 0 over and over, but every time a shape is removed, the shape collection gets rebuilt. The shape collection, the by index inside of a collision area, is a 0-based traditional array, which means if you remove something, everything has to be shifted to account for the empty space. That leads to problems with some other trickery we were doing before. But yeah. Okay, this should... Okay, that should still clean it up. Okay, so when we are creating the collision areas initially up here, say list of collision areas. And for each one of these, say collision areas equal to new list collision area. Then we'll need to change the name of that. Add. This is going to be collision entity category, collision areas. I don't like that. We need to change that name. There we go. All right. So for each one of these categories, we're creating a list of collision areas. Bullets. Enemies. All right. So this will be collision areas. Entity type. Add collision area. So we're adding that to the list. Entity shapes collection. That could be area independent. The entity shapes. Hello, Conduct. Welcome. Let's see. By category in a list of shapes. And each one of those shapes is going to use the shape index, which should be independent. Yes. So all of this goes up. So entity shapes here again. This is the type of thing that will be added. We'll create the list. So we create the indices. We create the shapes. Then we create the collision areas. This up to its relative order here. Yeah. Okay. So right after we add the shape indices. Bullet. I hit compile accidentally. It didn't like what we did. Okay. So we're getting a collision area. We have an entity category, and we have a shape index within that entity category. How are we going to get this? The category gives us a list of collision areas. That is equal to this. Now, the specific collision area is based on math with the shape index that we get. Equal to collision area list indexed by, just make sure it's an int, is shape index divided by collision area dot max shapes. All right. So this should give us which one of the areas to deal with. So now the shape index subsequently, anywhere else we're using it, we'll know which one we're actually dealing with. This would be get collision area. We use entity category, get RID. It's not that index. This is area. Area is equal to this. This collision area dot get RID. Off index offset plus that. Index minus. So an entity shape is going to, oh no. Yeah. An entity shape is going to report its index, which is the global kind of index track here. And so if we subtract the offset, if we subtract the offset, we'll get the index within that particular shape. Collision area is equal to get collision area, entity category, index. Area get RID. Minus collision area dot index offset. We remove the shape from that collection and we add the index back to the global collection. Should work. Okay, so now adding a collision area. Add index offset is equal to index offset. Add it to the list. We add this as a child of the area. It raises that event, okay? Okay, we know our local one, but this is a problem area. We're keeping the index here. We can process the index in this collision here. Not 100% happy with that, but plus area, local area is equal to problem. It's the colliding area that is a problem. The colliding area, we only know its index. This is all we know from here. We don't know what the other colliding areas' offsets are. We know what our category is. Here. We know what our offset in our category is, but we don't know anything about the other areas. we would need a translation between this as a collision area. Oh, but we do know. Okay. Okay. We need to interpret those indices as the global indices. This one, when we're interacting with the physics server, we need to know what the index of the area we're dealing with is. We could change this to the collision area because we will probably move this logic to the collision area. But anyway, where is it? Entity added. Setting up the shape. Applying the shape there. Getting the shapes, we add the shape. Fire it up. And we talk to the physics server based on the area that we're dealing with. But this part is okay. It's area RID. Yeah. We potentially need the area RID elsewhere. We could move this into the physics area, but we're not going to for now. Same with this. Back up into our collision area. So back into our collision area definition. We do an area shape entered. We have the colliding category here. Our local shape index is different. We are going to do plus index offset here. Say collision area. Is equal to collision area. And we move dot entity category to that. plus other area dot index offset. So we have a collision area collided now. And we can say on collision area collided, we can just interact with our shape collections. All right, what's still broken? Didn't fix anything. Potentially made it worse. Alright, let's stop, and we're going to run it on the Godot side entirely. I want to see where we're getting error states here. Here they go. Pause. Okay, our shape transforms are out of bounds. So the shape transform here shape position updated. Okay, so what we're having here, let's fix this. Our collision area, so we're calling get areas on that index, which is the index of the shape. And it's only if we get into the last area that we're going to get indexes out of bounds. Because we should always have something for that. So we're going to run it here. Fine, now we're getting into big numbers here. Okay. This should get us the second area. It's index offset. Yep. Okay, it is the second area. So we're generating a lot of errors here. That's our problem. which implies that we're setting, when we're adding shapes, we're not adding them to the same ones. We're potentially very close here. It's gonna take a moment for it to recognize what's going on. Let's just kill it. Adding it, we get the collision area. This is wrong. We need an index. That's why. That's why. When we're adding them to the wrong categories. Or we're adding it in the wrong index spot. When it starts to overflow into subsequent areas, those areas don't have the right number. Okay. That is next index. Okay. In theory, this should start working. We're still getting a decay. Let's run it in Godot. That should never be the case. Number is greater than the index here. Never be asking an area for a number greater than it like that. Starting a Twitch ad break here, so just going to keep talking through what we're trying to figure out here. Oh. We have a collision area for it. When we're getting the shape, when we're messing with the shape here, so we add the shape, it's this one. We're getting a shape minus collision area dot index offset. I was hoping that would work. We're still getting a shape out of bounds thing. Yeah. So, for those wondering, what we're working on is getting collision cleaned up. And one of the things that we're trying on it is to One of the things we're trying on it is to subdivide the indices into a different area. So if we look here, oh, set shape disabled. Where are we setting shape disabled? We're still in a Twitch ad break, so for those of you that may not be subscribed, well, if you're not subscribed, you're not seeing this. But I'm going to try to minimize some of that. We are going to have to add this stuff to the collision areas. So what I'm encountering is a lot of these area set things. I think we need to move those inside of the collision area because we're having to do this. And that's not great. Because we could call it global index and then the collision area can handle converting it. Right now, an outside entity has to interact with this. It's not the worst, but I don't like it. Okay. Not. Oh no, we started decaying. Stop. Let's try again. What's our error this time? 5, 6. We held for longer that time. There we go. Area collided. 4003 not present. It's on 235. Entity shapes. How is that not present? Okay, on entity added. Get the next thing from the shape queue. Use that index to get the area. All that together, we're going to make an entity shape. Get the corresponding shapes. We add it accordingly. Which means Right here. You. Yeah. Oof. We need to have a distinction between the global and the other, but for now, we're just going to try to narrow it down. Come on. You can do it. Yeah. All right. What's wrong this time? Okay. We got up to 3 to the 6th this time. That is better than we were. So let's run on the Godot side and find out what the error case is. Oh, well, that won't help. We had 2 instances of it running. I don't know if that was creating the problem or not, but 5th to the 6th, 7th. It's 3 to the 7th. 1, 2, 3. Physics time. Frame time is pretty long, though. We are chewing up a bunch of physics time. Yeah, we're getting close to 1/10 of a second on physics time with this many things. So this is just a bonkers number of collisions that are happening. We had better logic for spawning them outside. Then we could test it better. Okay, having this many collisions simultaneously is causing some problems. We are getting more than 243. Given that nothing is appearing at once, we are getting, oh my god. So there's 483 yarn balls, 486 yarn balls, and there's 243 blobs, And based on how I think it's actually happening, because the collisions aren't being chewed up. Like, we're not skipping the logic. We are having comparable to 243 times 486 collisions happening simultaneously, at least once a second. So losing this many frames, not too shocking. All right. Let's try to get some variable cases in here. We're going to our standard catalog, and we're going to load interactions here, timer interactions. We're going to give everything 10 seconds to live here. Then in our inventory, when we are iterating here, I think we have a physics yeah, okay, we're doing the physics process ourselves here. So if enemy, then position is equal to this. Else. Vector 2. And this will be we had a random elsewhere. Random dot. Hey, a Visual Studio update is ready. So we're going to get next double. Times from 0 to 1. All right, all right. So this is times 20 times 2 minus t, comma. We're just brute forcing this a little bit. This all to be a float. Okay, we are generating a random position on the screen. The game screen is 1920 by 1080. So what we're doing is we're getting next double, which is a value from 0 to 1. We're multiplying that times twice 1920. So we've got double the screen. Then once we have got that number, we are reducing that number by 1920. So that should get us a value from negative 1920 all the way to positive 1920. And we did this the wrong way. Category is equal to bullet. Okay, and we are going to have our load entities. The nano blob will, instead of movement rotate out, it will be movement cursor. Right, we are not getting blob collisions anymore. If we look, the yarn balls are getting removed when the blobs hit them, but the blobs are not getting removed. Which is not what is supposed to be happening. Oh, no, wait, that is the case. Okay, well. We are spawning 81 blobs at a time every time they will show up, and they're moving through everything. So we're getting a huge number of collisions happening very quickly. All right, let's see where our bog down point is on the Godot side. Okay, huge number of yarn balls to create. Number of blobs to create. We're not getting any errors. I think we're just getting a raw processing hangup. Okay, let's reduce the number of blobs by a factor of 3. It's not timing out. Blobs are timing out. I don't think anything is timing out. Not emitting any error states. We should not be getting this much lag at this many objects. Let's narrow this down a bit. Okay, they are timing out. There's just so many of them, it's hard to see. And it's supposed to be if a... Okay, yeah. The bullet collides with the other entity. So let's check that code here. Where's our entity? Position. Wide. Remove the target. Technically, if a blob gets through, the player should go away. The inventory grid that you're seeing is for testing purposes. Yep, player object's gone. Yep, and we're seeing the multi-collisions happen. Okay, there's a little hitch when that starts happening, and it keeps choking a little bit whenever we make that many at once. But that's 2 times 3 to the 6th that we're simultaneously creating. Sometimes. That's over 1,000 objects popping into existence simultaneously. We might need to still have some sort of logic to mitigate the number of things that we create at once. Because with this, we've got upwards of 8,000 things on the screen moving around. Not quite on the screen. The yarn balls make it off the screen in 10 seconds or so. So we're in a better place than we were last night. This is just short of 8,000 things on screen. We are still seeing some issues. So let's watch it in Godot for a bit. We want to see if once the slowdowns start, we get any of the... if we get any errors reported. Another thing we could do to minimize the amount of risk surface is to make it so every area has its max number of shapes created. It creates a burden up front during the load, but it would then remove the do I create a new one or do I grab an existing one? It's always grab an existing one. Thousand things on screen, no errors happening. Let's add entities here. So again, one of the things that we're going to be doing is making it so that once an entity is in the process of colliding, it will not collide again. Essentially having an invuln window where if an entity has already made a collision, as soon as that collision is accepted by an entity, then by default, the entity that is sending a collision and the one that is receiving the collision both go into a I am not going to collide anymore state. So it's in both directions. If I run into something and that something says I have received that impact, then I don't impact anything else during that period. There's some room for wiggle there. Like some of the collisions will continue to persist, kind of thing. But each of the types of collision need to be turned off in that scenario. Because, for example, like when a yarn ball hits a blob, they're not removed at that very moment. They are queued for removal. Which means things like it should immediately visually go away or similar. All right, we're starting to get some slowdown here. No errors happening. Let's turn on our profiler. Starting to get spikes, though. We have some degree of degradation happening. Physics 3D is firing. One thing I will say that is really annoying about Godot is trying to interact with the profiler while it's operating. Because if I do that, see how all those numbers went away? So I can't see what the values are. So if I stop it and clear it... Oh. Hey there, Dev. Welcome. We are trying to figure out what's costing us frames per second right now. Because it is eroding. There is some sort of leak or process leak going on where some stuff is still getting... Because when we start this initially, let's put the numbers real big here. But we're making a game. We're making a Vampire Survivors style game. The way things spawn and interact is akin... Well, what we want it to be is akin to how Noida processes a wand. Sort of. Okay. About 8,000 things in existence at once. We're holding it right around 60 frames a second. This is my first game. This is our 90th stream of doing it. We do 3 to 4 hours per stream often. I don't do a lot of work on it off stream. Often it'll be like research and the like. Okay, we are... Ugh. Oh, well, that's part of it. Let's solve for that real quick here. $960. So what we've been doing today is trying to solve some performance issues. We are past some of them. Not perfectly, but pretty good. Very nice. We can still see some problems happening here. Not the 8,000 cap. 8,000 cap should never happen. We are going to have to deal with that, though. We're going to need to come up with a way to throttle the number of things that come into existence at once. We are going to let this ride a little bit. To see how long it goes. Right now there, if you look at the counters in the upper left, we have frames per second and then the number of things that exist. That's the number of, like, the little blue blobs heading for the center and the number of little rolling balls going out from the center. Plus the little guy that you can't see because of the number of things. We want to stay at that solid 60. We have a limit of 8,000 things that can come into existence. Right now, 3 sets of 81 at a time, like every half second, I think it is. Yeah, it's like every half second, we are creating 3 sets of 81 objects. It's 81 because each one of them has 4 split into 3s happening when they are initially processed. At this rate of creation, and with them going away after 10 seconds, all of that is modular, by the way. We can technically change any of that on the fly. Like, I can make it so one of these has 243 spawning at a time. Just with that little drag and drop there. The little blobs spawn randomly around the screen and move towards wherever the cursor is on the screen. And the balls move in a random direction outward. If a ball touches a blob, the blob goes away. If the blob touches the player in the center, the player goes away. That is placeholder logic. So there is some sort of error case or memory leak case that happens if we keep sitting. I wonder if that's it. If we keep sitting at, what is it? Max objects for too long. Yeah, the player got touched. You can see. Well, you may not be able to see, but there's a red dot that is briefly visible in the center of the screen. It's only visible if the player's not there. It may not be visible because it's like 1 pixel. This is pretty good. Getting this many things spawning at once. So I need to have logic that makes it so that only so many things can come out of a given projectile. So we may need to make it so that instead of having each one of these happen iteratively, right now, split into 3 is exponential. That is, each one of the projectiles that is created, when it splits into 3 again, that is 3 more from each projectile. So it splits into 3, then there's 9, then there's 27, then there's 81. Which, while that looks cool, it leads into scenarios like this. I don't mind getting into seconds per frame or minutes per frame. When we played Noida, that used to be a focus of my stream way back, it was a running gag and almost a goal of a given run to see if we could create a weapon so ridiculous that it took the game ages to process a frame. We had boss kills, like fine ends of the run, where the defeat of the boss could take like 10-15 minutes to process the frame at which it dies. Oh, hey there, Drew. Welcome. I didn't notice you initially. Sorry about that. Okay, we've been holding for a while on this. pretty good. All right, what if we amp it up a little further? This is effectively 3 to the 6th at once. And 3 to the 6th at once starts to get us into a bad state. There is something going wrong at this point that is above and beyond anything that I've otherwise dealt with. Let's... because we're hitting entity cap a couple of times. That's to be expected. That's to be expected. Because again, we're creating a lot of things at once. 800 plus, like 800 to 900 things simultaneously, which burdens the creation process, since every 2 seconds, so we are creating a whole pile of things. And we're occasionally running into a limit. So if I then call these back down to where it was, do we get back to 60? Okay, we do. I still want to improve this. I still want to be able to hit some of these bonkers numbers. All right, well, for science, let's go into our entity manager. And do not worry about interrupting me, folks. I will try to notice your text as soon as I can. And I'm willing to stop and chat, whether it's about the code or something else, within reason. Let's go up to 10,000 again. 8,000 was a safe boundary for when we were transitioning over to having collision. We are going to go a little short of 3 to the 6th again. Since 3 to the 6th is a big problem. Okay, as we expected, 8,000 is still the safe boundary. Let's drop it back down, let some things fade out. See, when we're operating under, it's technically about 8.5, 9,000, somewhere in that range. Godot just has problems dealing with it. It's technically not just Godot. There's so much processing happening. Okay. We're going to keep 12 of those. We're going to drop you back down to 8 as a hard cap for now. We'll see if we keep it that way, but you know, it's a variable. Just have those be constants. I need to remember that. Constant. Max shapes is 2,000. That seems to be good. I wonder, you know, for science, more areas. Again, each one of these little triple lines that I'm adding makes every bullet split into 3 again in sequence. Okay. 2 times 3 to the 5th plus 3 to the 4th is fine. We do hit cap frequently. Here's 3 to the 6th. Interesting. Interesting. What if more? Nope, 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 nope. Not less, more. When I say more and I'm lowering a number, this is the maximum number of collision shapes inside of a collision object in Godot that I am creating for the purposes of words. For the purposes of tracking the collision of objects. So there's currently 3 actual collision concepts in the game. An enemy hitting the player. We may have player hitting an enemy, but... Well, there's player, bullet, enemy. In general, enemies hit the player and bullets hit enemies. As we go, we may add more complexity to that, but that's the baseline. Then, within physics in Godot, you have the concept of collision areas and collision shapes. Collision areas have shapes. If one area that is looking for a given area type overlaps another area that matches that type, a collision is generated. Because Godot's base handling of collision areas and shapes, like if I were to use Godot's collision trees, like object trees, is anything using those is way slower than dealing with it from the C# side, within particular limitations. There's specifics, but in general, it's way faster to do the processing that we're doing on the C# side. What I've been finding is more shapes in a collision area is more expensive than more collision areas with fewer shapes. So we've got logic now that instead of generating one collision area for each type of collision, we're generating, with lots of shapes in it, we're generating many areas with fewer shapes. I want to find the sweet spot here. Let's do an extreme case. 1-to-1. This should actually be very bad. Well, in theory, this should be very bad. Gonna be kind of upset if it's very good. I'm kind of annoyed that it's working this well at the moment. All right, we're getting some erosion. All right, here's our... Oh, no. It was our 3-to-the-6th case. It's still getting kind of chunky. All right, let's go back to something a little more reasonable. By consolidating it down, there are less collision checks that are happening on the Godot physics server. That is, while there are many shapes inside each area, there are fewer areas to compare. So, we don't have that level of multiplicity going on. All right, 3-to-the-5th, just under 3-to-the-6th. That's holding. Here's our critical case, 3-to-the-6th. Holding pretty well. All right. The manager. 9,000. I keep tabbing over for reasons I don't know. We're including the blobs in this logic. Couple reasons. One, the blobs are using one of the most expensive movement types, that's move to cursor. Because Godot has to constantly say, where is the cursor over the game screen, and what does that mean for world space? That's almost 9,000. Yeah, it still gets chunky. I don't like that. I think 8,000 is our safe spot. Again, we can always increase that if we want things to get more absurd, which is okay. Again, absurd is okay. In general, enemies wouldn't be spawning in huge numbers on top of each other like this. They would be spawning more frequently. Sixth. The 7th. All right. Critical edge case testing. Five to the 6th to the 7th. Big numbers, come on. Okay, we do get seconds per frame, right around 20,000 things. It says 1, but it's less than 1. Frames per second ends up, I believe, as an integer, but, well, not really. We're treating it as an integer. Okay. What if we just do 15,000? We're validating our ranges here. So this is 3 to the 6th being created simultaneously. So 15,000, we still don't have seconds per frame. We've still got frames per second. All right. Let's go into our standard inventory. We are going to keep one of the yarns. We are going to keep those. We're going to keep... We're going to add some spiral outs. We'll add a spiral in. This guy has come to sit with me, which is obstructing my ability to type. Do I have an item for spiral in? I must not. Not item, it'd be standard catalog then. Load item. Catalog constants. We'll use icon orbit for it just to differentiate, but item. In. Then we go into then we need to go into load items. Still need the blobs. In. We have some other icons that we could be using, but I had one with the mouse that was for our delays. We have an ad break on Twitch, so I'm probably just going to keep talking through some of the same stuff. Blank. Well, let's go to our standard inventory. Spiral in. Do an in for the blob and out for the bullets here. Five and 6. Not too upset with these results, ultimately. There you go. Let's add more blobs. Blobs can appear anywhere on the screen. They are appearing in numbers of 3 to the 6th at once. They try to spiral inward towards the cursor. It's essentially like a tightening spiral towards from where they start to where the cursor is. So we have just under 15,000 things on screen at once right now. They're spawning in great big clusters of 3 to the 6th at once. Each of them has 2 different movement patterns that they're executing every frame, as well as a lifespan timer that is happening every frame. So we have a minimum per entity of 3 things happening per frame, in addition to like drawing and collision checks. And we are doing the physics about 60 times a second, as well as the rendering about 60 times a second. Unless we reach this kind of calamity case, we hold pretty smoothly. And even at this calamity case, with this many things going simultaneously, it's ultimately doing very well. Yeah. I mean, for this many things, 2 frames a second, pretty good. Let's cull the things down noticeably here. Now I want to see if we reset. I need to let it fall down. Yeah. So we drop below 8,000. Super smooth. Again, the UI there is not end state UI. It's just big and visible and easy to click right now. Same way, I want a big fat, like, software cursor looking thing, like a rendering of the cursor in the world. And I want some drag and drop on the UI too, for visibility. 5,000 objects being created at 2 times 3 to the 5th, twice a second. All of them moving, having 3 different processes per frame going on, with full collision detection for all of them. It's pretty good. Again, we'll have to do something that limits the capabilities of splitting like that. Something to flatten it out. Like maybe within a given segment that it combines all of the multipliers like that. So, for example, instead of becoming 3 to the 5th here, it would actually take each one and add them together. So the first one says split into 3, as does the second one. And what that means is effectively add 2 in a fan. So it would mush them together and say add 5, then it would be add 5, then add 7, then add 9, instead of multiplicative. I think additive is still pretty good, even if you did the full 3, you know? So instead of split into 3 and then 5, it could be 3 and then 6. Odd numbers are better for that kind of split. Otherwise, you get essentially, you have to aim at an offset. With a split into an odd number, there's always the option of having a projectile firing in the direction that it was originally firing, with the others fanning off of it. But yeah, stream frames per second will be lower than what's actually going on, but I assure you, it looks really smooth. I do like it, though. I do like it. We have achieved something. Now, questions. Further tweaking. So we have 15,000, and then we have in our collision manager 500. About 250. I expect it's more about raw movement. So here, you can see the way that they move a little better here. So the little yarn balls move in essentially an expanding orbit. The slimes are going to try to converge on the cursor. They'll never reach it because they don't have long enough to live to do that. But they try to. You can have them just move to the cursor now. For extra fun, here's a spiral out and a spiral in on the little balls there. So it takes the behavior of a spiral out. It applies that motion. And then, following that, it takes the behavior of a spiral in and applies that motion. The reason that it's important which order it happens is that as far as the spiral out is concerned, the spiral in this case, the center of that spiral in moves along the spiral out path. Whereas if we reverse it, we don't get a difference because the entity appears at 0, 0. Its home point is where it begins. So instead, we get no difference. But it's that case where it's a spiral out in a spiral in, we get that odd behavior. Because it keeps trying to do a tightening loop as that center point is moving out. Additionally, when you fan out a spiral, you have combinations of tightening and expanding circles there. 3 to the 6th. Uh, 13,000, we're still moving. The 7th. Yeah. All right. Let's get some more of the screwy cases going. Come on now. There we go. That doesn't really make a difference. I think 500 things per shape was pretty good. Let's check our list of items here. Here we go. It is gate is a testing case. Move you up to the testing cases. Reason that Nanoblob is a testing case is you would never have in your inventory an enemy object. Okay, so we've got gate as a thing. Spawners, movement. Gate, wait 3. Okay. Then when we're loading... timer interactions, we're giving them 10 seconds to live, which is pretty good. Alright. We're adding a gate. We're going to reduce it down to 5 of our spawners, since we know that that gets kind of bonkers. They're going to go into standard inventories logic here. Okay. Okay, we are going to dot normalized. Then times 960. Okay. For reference, what this is doing, we could do this easier, but let's do this easier. vector 2. All right, we're going to do new vector 2 is equal to vector 2 dot right dot rotated a number which is dot raised radians. That exists somewhere. Where is it? Behavior, movement, rotate. Angle increment pi over 180. That's as good as anything. Pi over 180 times double times 360. All of this as a float. Right. Rotated. Oops. I times that. That. Okay, so we take a vector pointing directly to the right and we rotate it a number of degrees between 0 and 360. And then, because that's a unit, and then we multiply that times 960. 960, which will create a point somewhere on the edge of the screen given the width of the screen. I'm sorry, somewhere on a circle, the width of the screen. Okay, so the little yarn balls are going to they're going to split into 3 in an outward spiral. They're going to wait 3 seconds, and then they're going to split into 3 again and move in an inward spiral, while still moving in an outward spiral. Now, for more fun, instead of that, we are going to say they're going to split into 3, but then they're going to split into 3 and move into a spiral. So you can see they slowly move outward, then they split. So for still more fun, they split into 3 and move outward. And then they split into 81 in spiral. And the blobs don't stand a chance and are immediately annihilated as soon as they enter the screen, because it's just a maze of death approaching them. But you can see these little starbursts forming around the edges. That is them splitting into 81. You get that split into 81 because there is always a delay. There is always overlap. So if it splits into 3, it rotates each of them a little bit to create a fan on kind of a 90-degree arc. And then on that same position, they split into 3 again on a 90-degree arc. So eventually you start to get those degree overlaps as far as where they're aiming. Which is another reason to try to squish the splits. We may be able to accomplish that. We'll probably try to accomplish that. Where it will iterate through a given group, deconstruct it, find all of the split logics, and mush them together. There's a limit on that, though. There's a limit on that. We will have to see. But yeah, we've come a little bit. We can easily handle quite a few objects on the screen. All of these objects are capable of collision, and we are doing a lot of processing on them simultaneously here. An interesting thought. Spiral in first, but spiral out. When do I think it'll be done? Unclear. A big part of the limitation of this, as far as how it's going on here, is the complexity of what we're trying to achieve with this motion. As far as completion, I can't speak to that. As far as testable, like playable demo stuff, we're getting closer. We don't have any of the actual game state going, but you can see the basic logic happening. We can see the basic user interaction. This whole grid is probably going to be something that has to appear on like a pause screen kind of thing. Because to be able to interact with it, it needs to be big and obvious, but it also just chews screen real estate. So I don't want it to be tiny. As far as legibility is concerned. It ultimately depends on how the game operates and what you want to accomplish with it. We're kind of doing a bit of a moonshot here. if I just wanted it to be like, some very fixed weapons and some creature spawning and similar, we could probably have banged this out well in the past. But we've had to revise things for performance quite a bit over time. Again, we want to be able to have this level of stuff active at once, like 10,000 bullets and enemies active in the world simultaneously, because we want to be able to get to these calamity cases where the capabilities of the game are strained in order to make things absolutely ridiculous. That has led to a lot of significant rewrites of the code. We started with bog standard Godot, everything in Godot's logic. We moved away from all of the standard Godot nodes into very scripting driven, but still using GD script. And we've now moved on to pretty much everything except some critical elements happens on the C# side. With additional kind of trickery. For example, let me see if I can make it happen here. No, okay. Let's see if it happens when we... but all of the rendering is actually done by shader. So all of these things are a texture sheet, a sprite sheet. But the actual rendering of the sprite sheet is not through a sequenced animation object or anything like that. This is all done on the GPU as far as each animation frame. Every ball rotates. The player does the little kind of bounce and squish standstill animation. You don't get to see them for any period of time, but the blobs bounce. All of that's done in the shader. All of the rendering is done using a Godot object called a mesh renderer, which takes all of these different entities and renders them in one very swift GPU pass, instead of rendering them each as a individual texture object. All of this to refine it, to get this performance down super tight. Then on top of that, again, every frame of movement that happens, every physics frame, every one of these steps is being processed. So the balls want to move in a random direction from their point of origin out. Then, based on that point of origin, they also want to spiral inward to that point that's happening. Then once they have, after 3 seconds, they also try to spiral out from that point. That movement is going to fight with all of that other movement, and it's creating this pattern that we see. This is not how the end game state will work. Instead of like it splits into 3 and it moves in a spiral, it would be a composite of things. Like that single cell on the weapon might be split into 3, move into a spiral, and explode on impact. And it would have like a cutesy name or something like that. So that everything that you get is some sort of substantial change in the behavior of the object. So a given run in this is much less about finding known combos. If I get the boomerang and the 4-leaf clover, it turns into the sword at level 10. And it's much more, well, I found boomerang motion and I found explode after 3 seconds. And it turns out that combination works really good if you combined it with the homing mouse, But there's no guarantee that I'll ever get that again, because the way I'm building it means I can have a ridiculous number of permutations of these behaviors. This split into 3 is a module that can be combined with other modules and combined with other modules and fit into one cell, one massive behavior chunk. So, to put it another way, it's got a lot of leg to it. It's got a lot of room to breathe. With this done, though, we can move back into what I'm calling interactions. We have implemented our first one, and that's lifespan. We are unlikely to use lifespan as a socketable one in the same way, because it is essentially a ticking bomb on the entity as soon as it pops into existence. But it might still be something that we incorporate to say, hey, it has a lifespan. Its lifespan is 10. And it might be that it normally has a lifespan of, 20, but as soon as that lifespan of 10 part of it enters existence, then it has a shorter lifespan. Now, I don't have a way of applying that on the fly, but that's what we're getting to. We might have a behavior that is single shot, like the split into 3, but its whole point in existence is to slap another timer interaction on the object and say, hey, after 3 seconds, do a thing. After 3 seconds, explode. After 3 seconds, turn into something different. All kinds of stuff can happen. But, so we've got timer interaction. Right now, lifespan is plenty. We only need lifespan for our purposes so that we can make it so a bullet does not live forever. It does not consume space in the world forever. Enemies will not really have a lifespan. I can add another timer interaction that says if they get too far away, remove them. We want a collision interaction. We want logic here that is, if I collide, I'm going to tell you something. Now, that tell you something might be, you're going to take X points of damage. On the enemy side, it might be it has a health pool. And the health pool says, I react to take damage events. So if it takes damage, it might eat that event. It says, okay, I accept the take damage event. And I'm going to queue the object for destruction. If I hit 0 on my damage counter. That would also be able to apply to the player. The player will handle it differently, though. But the same logic would happen. If the player receives a I'm going to take damage event, then it will acknowledge the event in the same way. But yeah, so that'll be our next one, I think. Our next one is going to be adding collision interactions and getting more of that going. For funsies, let me run it on the Godot side and show you what the structure of the tree is at runtime. So then we go into here, and we're on our remote tree. This color rectangle here, which, again, might be hard for you to see. This is the red dot in the middle of the screen that you usually can't see. This is the label on the screen that shows us our frames per second and our number of entities. Here's our entity manager, the thing that is actually making them move around. Here is our multi-mesh instance 2D. That is how the mesh renderer operates. Everything, as far as every bullet, every creature on the screen is rendered by this thing, using shaders. And then here are all of the different collision areas that we're creating. there should be like 16 of them. No, I made the number much smaller. Standard collision manager. Oh, no, that's because entity manager allows 15,000. So, like, 30 of them should be in existence. It's way more. Is that? Oh, that's right. Because we're doing 2 times that. It's like plus a little. I'll have to check that math. But anyway, these are all the collision areas. You can't see their contents. That is a limitation of the Godot UI side, is it can't see a lot of the stuff that I'm doing. It behaves accordingly, but the UI can't see it. But yeah. I'm pleased. I'm pleased. Getting as far as we did today was nice. One, two, three, boom. Pretty much all of the stream, James. We're just wrapping up here. We have time to show what we've accomplished today, though. So I fixed a core part of the problem, let's say. It was collision. And one of the things, like, okay, so I've set it to allow 15,000 things. Let's just put it to 20 so we can show the whole case here. I put 15 because 15 still gives you frames per second. Then we'll go into our standard inventory. We're going to load 5th, 6th, and 7th. Yeah. Starts out very mundane. Got blobs spawning. They move towards the center. If they touch the player will go away. Boop. Okay. But now we're going to... We'll spiral the yarn balls out. And then after 3 seconds... split into 3, then 9, then 27, then 81, then 243, then it's like 729, and several thousand. So as we approach 20,000, it is going to start to slow down more and more. So we can see it choking wildly around this value. But we know that that's a number of things. Exactly, James. And I do want to keep that case. I want to keep that case. Seconds per frame, we want. Let's pull it down to 10. And we'll just jump straight into the mayhem here. Several thousand spawning at once. It slows us down a lot. We still need to figure out a way to put a handle on that. But at 10,000 spawning a couple thousand at once, 5 frames per second, which non-trivial. We've got 10,000 things pretty much on the screen with collision handling. And then if we put ourselves back down to our 8 limit, which we know is pretty friendly to what we're doing within limits. Here's 3 to the 6. This is where it died last time. They go away after 10 seconds, by the way. So we're spawning 3 to the 6th at the same time. Works out great. 3 to the 7th. It's going to have trouble doing that, but it's trying is the thing. So anytime it's able to spawn a whole bunch, it's starting to slow down. But we drop down to 3 to the 6th again. Frames per second recover. So how we did this, let's look at our collision manager, and we did a lot of footwork here. This is what we did. So what I discovered is that collision areas start to have problems as they approach a particular number of shapes, and it seems to be a little past 2,000. It's between 2 and 3,000. They start to slow way down. So what I did is said each of these shapes, each of the collision areas has a limit. So we've created... There are way too many collision areas. Oh, no, I get it. That's because we're creating extra. So I can change the number of these, and we can fiddle with this some more. I think this is ultimately something that could be a nice variable to add to my master resource object. To pass this in and make it so it is a static value that gets changed on implementation here, on construction. So we could add in a global call to get the master resource that says, what is this value? Is this value greater than 0? And if it is, use it. Otherwise, use 500. But I could do things like 100. And we run it. Actually, let's run it on the Godot side so you can see. Switch over. Well, quote unquote C. So here's my collision manager, and instead of just having 3 areas under it, it now has many areas under it. It's going to be 80 times 2 plus 1. There's a little fiddliness in here that isn't working right as far as these numbers. And I can set their names. I could go in and set their names, but, I haven't yet. Okay, let's get our calamity case going again. So the trick is to find a sweet spot as far as the number of areas that we have, because every area is potentially a collision check with every other area that it might collide with. So we drop back down to the 6th. So we can see this is still more expensive. It can recover, but there is a greater expense happening here. So 500 seems to be a nice spot. And it's something that we could test with some more. It required some fiddling. About when we add a collision area. Collision area is instantiated. No, it would need to be after. That would be in the add function. So in add collision area, we make a new collision area. Area.name is equal to area index offset. Messy, but here. Show what that does. Oh. I missed a semicolon somewhere. There we go. Oop. Yep. So 1 is the player area, no offset. 2 should be, I think it's bullet. Its enemies are bullets. And then 3 is enemies or bullets. And this offset is in order to differentiate. So we have a global index for shapes, like the shapes of entities. We have a global index for them that we cycle through. Then each of these areas handles a subset of them. But because they are Godot physics areas, the index of the shapes is not only, it is a zero-based array that must not be tampered with. So the first collision area, index 1000, means nothing to it and cannot mean anything to it because it's from 0 to 499. So we have to select the area based on that and then subtract the offset from the global index ID that we get to get the local shape. And by doing this, this means that we can compact them down and again find that balance of number of collidable things to performance of number of shapes in those. So it is the complexity of the aggregate shape versus number of collidable shapes or collidable areas. Very fiddly, but we made it places. We made it places. But we accomplished our core goal today. It did not work out in the direction that I initially thought. But the results were interesting. The results were very interesting. It's like Sherbet is going to try to snuggle up with Mason there. We learned something about Godot's collision handling, or at least collision handling objects, that we didn't know previously. And I think that's a big value that we obtained there. Again, another dial to turn as far as fine-tuning. We'll see how it ultimately plays out. Next time, we're going to start working down the road of getting the collision to happen how we want it to. Twofold, we need to have the logic for things like taking damage. But we also need to have logic for consuming a message or not. So when something takes damage, what I want it to do is stop taking damage for a period of time. So essentially, damage iframe. That doesn't mean it will stop colliding, and it doesn't mean it might not have another collision interaction, but the take damage thing will probably have like a, wait a half second before you can take a hit again kind of stuff. I kind of want to use, enemies might have a shorter cooldown time on taking a hit. But bullets will have an even shorter time as far as inflicting damage and going away most of the time. That kind of thing. We're going to have to figure out those kind of things and get those in place. Then that gets us into the core interactions are in place. After that, I want to start wiring up the player to be an actual thing. Like, the player entity is a critical object, and will have its own important state. Player health will be something that will be tied into display. The player's inventory will get merged into that. All of this stuff. We'll see how it all plays out. But in any event, I hope everybody liked what they saw tonight. If you did and would like to see more, remember to like, follow, subscribe. All of those good buttons will help you find this content more in the future and will help the channel grow. If you'd like to support financially, you can do so through memberships, subscriptions, Patreon, Coffee, all those things I have links to in my LinkTree, found in the description and in my profiles. With all that said, I hope the rest of your day is good, and I hope to see you next time. Good night, everyone.